Okay, here we go, and hopefully some of you are watching this on YouTube. I will upload it to both Educreations and YouTube in just a few minutes. This one's going to be short and sweet because hopefully a lot of you have already looked at the examples on the pages I passed out last Friday. This is Lesson 4-2, and it looks a little different because it comes from a workbook based on the book we have, slightly different than the pages we've been seeing before. But it's going to match up to Unit 3, the 3-5 stuff that I'm also going to upload. Same idea, direct variation and slope. So let's just jump right in and just make sure you see what's being illustrated here on these examples. A direct variation, it's the same thing as the slope. Okay, so in these particular examples, you're going to hear me say some words that we'll really start using more and more as we start learning about a linear function. Well, the rate at which this line changes in this particular case is the rise. So you go from 0, from the origin, count up 1, and then over 1, 2. That's where you intersect the line again, right? So the rise is 1 over 2. That is the constant. So the constant is 1 over 2. And for the purposes of this page at least, k is equal to m, which represents slope. So the slope of the line, in this case, in this example, is 1/2. M is 1/2. So we can figure that out easily on a graph. In all of these pages, it looks like it's really given. But again, just looking at our graph, pick a point that we can start from. In this case, it conveniently starts at 0, 0. Count up 1 and over 2, and you put the 1 on top. That's the y, the rise, over the run, which is 2. In this case, both of those are positive, so it's a positive slope, 1/2. Okay, let's look at this next one, see if there's any point to be made on it. Suppose y varies directly as x and y is 30 when x is 5. Well, what this did is it went ahead, just like we were doing on Unit 3.5 or Lesson 3.5, where I told you to put the 30 over the 5 equals, all right, what's missing, in this case, the k. I'll tell you what. Scratch that. Let's look at it just a different way. The thing to do here is to think of the formula as y is equal to kx, just like they have. It tells us that y is 30. I'm sorry, that should be a 30. When x is 5. So we should be able to solve for that and find k, which they did. Divide 30 by 5, I get my k of 6. Okay, so you can use that constant, y is equal to 6k, or 6x, for anything they give you. If they were to tell you that y is equal to 18, well, divide 18 by 6, you get x is 3. All right. So you're going to be able to use that particular little format for every single problem, I think, that you're about to see. Y is equal to kx. Put the variables that they give you where they belong, and then solve for the k. That's going to be over and over on these pages. Let's see here. Name the constant variation. Well, for whatever reason, they wanted to make the point in the answer key that the constant is -2 and the slope is -2. I don't really care if you write that twice. Constant and slope are the same thing when it comes to lines like this. Okay? And so you can just write the same thing that you see on each one of these. Number 2, the constant would be 3, and so forth. This, starting at number 4, looks like what we were talking about above on the second example, I think, k times x. It tells me that y is 4 when x is 2. So if I just flip that around, I could say, or if I solve for k, divide that, k is now also 2, and so we could say y is equal to 2 times x, and for whatever other value they ask us to solve for, just stick what we know in. So number 4 says find y when x is 16. Well, that's easy. If you stick 16 there and multiply by 2, in this case, y is equal to 32 on number 4. Hopefully you guys, doesn't seem like that would be too hard for you guys to grasp, considering everything we've talked about. The only difference here is that we changed up the variables. Same idea as what I just got through solving, except we used the distance equals rate times time equation, and our r is like our k. So you want to solve for the r in each case, and that is going to be, if we were to graph it, the slope. So I think we talked a little about this a few days ago. If we have a speed of 45 miles an hour, that's going to be our rate, and your line is going to look something like that. If you were to go faster, the line would be steeper. Right? Alright, I really think you guys can take the rest of these examples from that little bit of guidance. Most of you are probably already done, but let's see some completed practice work whenever you come in tomorrow. Have a good night.